Welcome back to Agent Mode AI, the podcast exploring the cutting edge of autonomous agents. I'm Kim.
And I'm Darren. Great to be here again. Last episode, we dove deep into multi-agent collaboration, showing how different AI agents can work together, sharing information, and delegating tasks to achieve complex goals. It was all about the power of teamwork in the AI world.
Exactly. And building on that, today we're tackling something absolutely critical for any AI agent that truly feels intelligent: memory. Our topic for episode 4 is memory that matters: how to give your AI agents real context and recall.
This is a game changer, Kim. Without memory, an AI agent is essentially stateless. Every interaction is like the very first one. They're stuck in their repetitive loop, unable to build on past decisions or adapt over time.
That's right. Memory is what transforms an agent from a simple tool into a persistent assistant that learns and improves. It enables contextual continuity, allowing the agent to remember prior decisions and personalize its responses. Imagine an agent that actually remembers your preferences, your previous questions, or the context of a long-running project.
It's the difference between a chatbot that always asks your name and one that greets you personally because it remembers your last conversation. This personalization and ability to recall past interactions is what makes agents truly powerful.
So what do we actually mean by memory in the AI context? It's not like human memory, but we can think of it in a few ways. First, there's short-term memory. This is primarily handled by the prompt context window of the large language model itself. The agent can remember everything within that current interaction up to the token limit.
But that short-term memory is fleeting. Once the conversation goes past that window or the session ends, it's forgotten. That's where long-term memory comes in, typically implemented using vector databases. Tools like Pinecone, Weavy8, or ChromaDB are fantastic for this. You can convert past interactions or relevant information into numerical embeddings and store them, then retrieve them based on similarity when needed.
And then we have episodic memory, which is essentially structured logs of past interactions. Think of it as a detailed journal the agent keeps. It records what happened, what decisions were made, and the outcomes. This can be stored in a more traditional database alongside the vector embeddings.
So how do we actually implement this? The core concept for long-term recall is using embeddings. When a new query comes in, the agent converts it into an embedding, searches the vector database for similar past memories or relevant information, and then includes that retrieved context in the prompt to the LLM. This is a classic example of retrieval augmented generation, or RAG.
Many popular agent frameworks already have robust memory modules built in. LangChain, for instance, has various memory types you can plug directly into your chains and agents. CrewAI also provides ways to manage a crew's shared and individual memories. And AutoGen allows for stateful conversations between agents.
Let's make this concrete with an example. Imagine an agent designed to help you with daily communication, like drafting emails or social media posts. With memory, this agent could remember your specific writing style, your preferred tone, whether you like formal or informal language, and even your common stylistic quirks.
It would recall past revisions you made, learn from your feedback, and over time become incredibly adept at writing just like you. Without memory, it would be a generic writing tool. With memory, it becomes your personalized writing assistant.
Now, a few tips and pitfalls. First, don't store too much or irrelevant memory. Just like humans, agents can get bogged down by too much information, especially if it's not pertinent. You need a good strategy for what gets stored and what doesn't.
And watch out for forgetting when switching sessions or if the memory retrieval mechanism isn't robust. Ensuring continuity across different interactions is key. Finally, train your agents to summarize and tag memory effectively. A well-summarized and categorized memory is much more useful than a giant, unorganized text dump.
Absolutely. Memory is the secret sauce that takes agents from cool tech demos to truly intelligent, adaptive partners. It's what allows them to build relationships with users and become indispensable over time.
So, for our call to action this week, if you have an existing agent, try adding a simple memory component to it. Even something as basic as storing past user preferences in a JSON file and recalling it can make a huge difference in how the agent feels and performs.
Experiment with a vector database if you're feeling adventurous, or just use one of the built-in memory modules in frameworks like LangChain. See what a difference it makes.
That's all for episode 4 of Agent Mode AI. Join us next time as we dive into another crucial aspect of agent development, giving agents tools, connecting AI to the real world.
You won't want to miss it. Thanks for listening, and we'll see you then.